Hello students, welcome back to OrganiChemVerse. Today I am going to solve a numerical based question wherein you are supposed to find out what are the final products A and B and then take a simple ratio of carbon to oxygen. First I am going to write the reaction here wherein an epoxide is going to react with a reducing reagent called lithium aluminium hydride. Epoxides are cyclic ethers. So you can name this as 1,1 dimethyl epoxide. So what is the function of this lithium aluminium hydride? It is providing hydride ion. So this is a kind of nucleophile. Because of the electronegative oxygen, it's going to form a partial electropositive carbons here. So the hydride ion can either attack on this carbon or this carbon. But due to steric hindrance, this hydride prefers to attack this particular carbon, right? So when it attacks here, the ring will open up. So the bond is breaking here. This, whatever polar bond is there, it will break. So how to write the product? So you can write like this. This will become O minus. You see on the same carbon, we have methyl group. And what about here? Earlier it was CH2. Now it will become CH3. Since you have CH3 on this carbon, right? There are 3 CH3. You can write like this. It's easier this way. Or you can write simple bond line structures also like this. Okay. Either way it is correct. All right. Now, it is treated with H3O plus. So in the next step, it's providing the proton to the oxide ion. So it's from the tertiary butyl group, right? So you can call this as tertiary butoxide. The tertiary butoxide is going to pick up the proton to get neutralized to a tertiary butanol molecule, right? So this is the first product. If you are already familiar with this concept, maybe in the first step itself, you can write this tertiary butanol so that you can quickly write down the next product, right? So now it is treated with sodium. Whenever an alcohol is treated with sodium, it's undergoing simple a kind of acid base reaction because of the acidic proton over here. So what salt are we going to get here? We are going to get a sodium salt of the tertiary butoxide. What about the hydrogen? It escapes as a gas, right? So what is the purpose of doing this? This is a kind of a strong nucleophile, right? So this is a weak nucleophile, whereas this is a strong nucleophile. You can see in the next step that it's going to be treated with an aromatic compound. What is the aromatic compound here? You can see that this is a nitrochlorobenzene, right? So what is the next reaction? It's a simple aromatic nucleophilic substitution reaction. See, generally chlorobenzene will not undergo nucleophilic substitution because of the plus R effect. So you can see that there is a partial double bond. Breaking this bond becomes very difficult. So how to make it easy? You can introduce some electron withdrawing group over here so that it will be easier. In fact, they are giving you a hint here, right? That it's undergoing a nucleophilic substitution reaction. So you can just think that the oxygen attacks here, the chlorine will leave, right? So you are going to get a product like this. Now, in the last step, you can see that it's going to be treated with concentrated hydroiodic acid or maybe hydrobromic acid. The reaction is going to be similar, okay? So now, what happens in the first step? I'm going to write here itself. The first step is always protonation of this oxygen. Now, where the iodine will attack, as I told earlier, it's kind of, right? So it's very difficult to break this bond, right? So due to the electron withdrawing group here and also the resonance, it's quite difficult. So what happens here? This is where the bond will break because it's kind of forming a tertiary carbocation also, which is quite stable. So the tertiary carbocation is going to interact with the iodide ion and it's going to form a tertiary butyl halide or iodide, right? And then what is the other product? You're going to get para-nitrophenol. Remember, benzene with OH is a phenol. So now, which is A, which is B? So they're giving you a hint also here. The product containing oxygen. So this is a product containing oxygen. So I will mark this as B and this as A. Now, what is the question? You're supposed to take the ratio of carbon to oxygen. Very simple. No need to take mass and all. Okay, just count the number of carbons. So we have 6 carbons here, right? This is carbon. And how many oxygen? Many students make a mistake of taking oxygen either from here or maybe from here. They will completely forget about this nitro. Okay, don't do that. They're asking all together, right? So 2 plus 1, 3. So you're getting a simple ratio of 2. Therefore, the final answer is 2. Okay, so you can see that we are including so many reactions. So here we are doing ethers, right? And here it's a reaction of alcohol. Here it is a reaction of haloarenes. And again here reaction of ether. So like this, many concepts will be clubbed together, right? And then the question can be framed. So that's why you should always correlate and study. Only then you can solve such questions. If you still have any doubts with respect to this, you can always comment your doubts in the comment section. And don't forget to subscribe the channel. Thank you.